So I started this problem in a different video and I'm going to finish it in this video. So we were given some quantities, some values up on top of the problem, and we're supposed to use them to get the answers for the rest of the problem. So right now we've got log base a of 1/3. And again, I'm going to be using the quotient rule for this problem because I have a fraction here. So what I'm going to do is write down log base a of 1 minus log base a of 3. And so at this point, just remember that log base a of 1 is actually a pretty number. This is just a 0. Okay, this was one of the rules, by the way. This was the rule number 5. Log base anything of 1 is always a 0. So that's why I can write down a 0 right there. And also the log base a of 3, this was given to me as 0.477. So the total is going to be negative 0.477 at the end. This is it. Okay, we now have to work out the log base a and then the square root of a. So log base a, square root of a. So this one requires a little bit of knowledge about exponent rules and how to rewrite something like the radical. So by the way, there's a power of 1, there's a power of 2 right there. That's called the index. So the very first thing I'm going to do is rewrite the expression without the radical, but with an exponent instead. So I'm going to write down log base a of a to the power of 1/2. Okay, so that's what I'm going to do first. And why am I doing this? I'm doing this because now I can use the rule that we have in part 4. If you have log base a and the same a again repeats with an exponent, then the answer is going to be just the exponent. So this is rule number 4. So according to the rule, if I have log base a of a, we can pretty much like ignore all that stuff, and the answer is just going to be 1/2 at the end. So that's the end. That was pretty straightforward. Okay, now log base a of 2 times a. There's nothing in the middle. That means multiplication. And again, remember, multiplication reminds us of the product rule. So what I want to do is put a log base a of 2 by itself, and then a log base a of a by itself. Now, I'm going to pull the log base 2 of log base a of 2 from up here. Log base a of 2 is 0.301. So for the first one, I know the solution is going to be 0.301. But what is the answer for the second part? What is the answer to this one? Log base a of a. Well, this is kind of like the one we did before it. It's the same sort of idea. I have log base a of a. The question is, what's the power? What's the exponent? Well, the exponent is just invisible. That means it's 1. So this whole thing, it becomes just the number 1. And so 0.301 minus 1. So far so good. All right. Now we have log base a of 3, all divided by log base a of 2. Okay, the problem did not put parentheses. I like to put them there. This one, be careful. It is not the quotient rule. It is not saying the same thing that we had up there before. It does not have log of a fraction. It's a fraction of the log. So this one is literally the answer to log base 3, which is 0.477 divided by the answer of the log with the 2, which was 0.301. And put them in your calculator and you get the final solution. So it's roughly speaking 1.585. It actually is not. It's 1.584717 and so on. But I'm going to round to 3 decimal places because all the other problems were pretty much the same. Okay. Finally, we have log base a of 5. So here's what folks are usually tempted to do. They're usually tempted to do log base a of 2 plus 3, and then they want to write it as log base 2 of 2, or log base a rather of 2, plus log base a of 3. Now all this is pretty much complete nonsense. This is all false. We cannot do this, okay? We don't have a rule for addition. We have a rule for multiplication. If I start with a product, then I can break it apart, or if I start with the division, I can break it apart, but I cannot do it if it's addition. So for this one, actually, I cannot find the answer with the given information. So we're just gonna stop right here and we're gonna say this one does not have a solution for now, okay? Eventually, when we'll have a calculator, we'll be able to plug everything into the calculator and get the answer to this problem.